Okay, hello, welcome to my channel. Now in this video, we want to consider this integral question from the 2022 JEE Advanced questions, right? Math questions. So this is from the question 1, right? Okay, so we are given to find the value of a, okay, from this given integral equation, that is integral from 1 to e of a function of x dx is equals to 1, where a here lies in this interval from negative infinity to 0 and union from 1 to infinity. So we are asked to determine which of the following statements is true or are true. That is to say, more than one of these options can be true. The first one, which is the a, tells us that no a satisfies the equation. There is no real number from the union of this interval satisfies that equation. And the second one tells us that an integer a satisfies the equation. So an integer from this interval, the union of those intervals satisfies. The third one tells us that an irrational number from the union of those intervals satisfies the equation. And then the last one tells us that more than one value of a satisfies the equation. So in fact, we are going to determine this when we are able to find the value of a, and we are going to find the value of a when we successfully solve this integral equation. So let's see what we have. Well, I'm not going to rewrite the integral here, right? I'm just going to start off at once. So let's start off by trying to see what we can do, right? So look at this. This is the natural logarithm of x raised to 3/2, right? If you differentiate that, take note, the numerator is just raised to power 1/2. If you differentiate 3/2, right, notice you are going to maybe bring it down first and then subtract 1 from it. Subtracting 1 from 3/2, we're going to have 1/2 as a power. And that's what we have at the power, right? Okay, and you notice this is just a function of a function, meaning that we are going to differentiate the inside function as well. For the derivative of the natural logarithm of function will give us 1 over x. You know, just the natural logarithm of x to just be 1 over x. So we have this part, we have this part, and we have the dx, so we just need to maybe get a constant multiple. So that means if I can multiply this by negative 3/2, right, that will be the constant that will come down if we differentiate that, and that means I'm going to have to balance it by multiplying this by negative 2/3. Okay, that is just by saying we're multiplying the integrand by 1 of the form negative 2/3 times negative 3/2. Okay, so let's just see what we can do. Well, the u sub is going to take the shape u equals to say let u be. Well, I'm not just going to make u to be this term, okay? No, I'm noticing that this place is a constant, so if I differentiate that, it's going to become 0. So we just say let u be a minus the natural logarithm of 3/2, right? In fact, I prefer the ln of x at once. Okay, but anyway, let's just continue since that's what we've been given to use. Okay, so we can use du. Okay, just differentiate that. Du will be, well, the derivative of a with respect to x will be 0, and then we differentiate this term here. This is going to be negative 3/2, right? We multiply it by the natural logarithm of x, okay, and then we subtract 1 from 3/2, which will just give us 1/2. But then we are not done, because we need to multiply this by the derivative of the inside function, and that means the derivative will give us 1 over x, and of course the dx here, we can put it here. All right, that's very nice, isn't it? So as you can see, we have negative 3/2 here. We have 1 over x, which is 1 over x, this x here, all right? And then we have the natural logarithm function raised to power 1/2, and we have the dx. In fact, the whole of that can be replaced with this. So we are going to say this is the same thing from that question, right? It's the same thing as negative 2/3, then the integral. Okay, we have negative 3/2 over x, and that, and that, and that, which is the same thing as du over, well, this is going to be x. Okay, we've used the x, that is just a minus that, which is in terms of u, and then we raise it to power 2. Okay, very nice, isn't it? So you notice the whole of this is what we called u, all right? And then we took the whole numerator to be du, all right, by multiplying that by a constant, which is negative 3/2, and then balancing it by multiplying by negative 2/3, okay, and then that. But we have one more thing to do, that is the bounds of integration, all right? So we notice this is from 1 to e, okay? So when x is 1, let's see what u will be. Well, when x is 1, you notice that the logarithm of 1 to any base that will make it well defined, the natural logarithm of 1 to base e is just going to be 0. And then raise 0 to that power, just have 0, and then a minus 0 would be a. So in fact, when x is 1, this place will be a. And then we go up there and see what we have. Well, when x is e, the natural logarithm of e will give us 1. Okay, so we have a minus 1, right? So this place will just, in fact, going to be 1, a minus 1, sorry. Okay, so that's it. So we are done with that. So we just need to integrate this and see what we have. Well, this is going to be negative 2/3, right? we multiply it by, well, the integral of this will just give us negative 1 over u, right? Negative 1 over u, and then we can take that from a to a minus 1. Okay, so maybe I can put this constant out front. So we're going to have this to be 2 over 3, then into, well, when we substitute a minus 1 in place of u, we're going to have 1 over a minus 1, right? And then we subtract, when we substitute a in place of u, we're going to have minus 1 over a, right? And that's very nice, isn't it? Well, we are done with the substitution, but notice, remember that this was equal to 1, so maybe we just equate it to 1, equate this to 1, and then equate that to 1. Okay, so let's see what we have. Well, here I'm going to try to make a subject of formula, and that is going to be by clearing these denominators, all right? So maybe let's do this. It is an equation. So I'm going to say, let's multiply both sides by 3a minus 1 times a. That is to say, I'm going to multiply the left-hand side by 3 times a minus 1 times a, right? And then we multiply the right hand side by the same thing. So we multiply the left hand side, we're going to have, this is 2 over 3, 1 over a minus 1 over a. That is just the left hand side we equate it with. I'm going to multiply the right hand side by the same thing. In fact, let me just do this. Okay, so if you multiply both sides by that, and then I'm going to clean from here to the second to the last step, and then we are going to see what we get when we multiply that. Okay, so as you can see, when we multiply 3a minus 1 times a to both sides, we're going to have, well, you notice 3 and 3 will cancel, all right? Then we multiply a minus 1 to inside, we're going to have, this term will become just 1, right? Then this will give us just 2a there, and then we subtract, well, we're going to have 2a plus 2, right? And then we're going to equate it with, when we multiply this by 1, we're just going to have this. So you just check that out. Okay, so let's see, this and that will cancel. We're going to have 0 here, and then this will be 3a squared minus 3a. In fact, we can rewrite this as 3a squared, right, minus 3a minus 2 equals to 0. So we have to solve this quadratic equation. Okay, nice. So let's see. Well, this, we can't factor this. You know, you multiply this with that of a negative 6. No, we can't factor that. So in fact, let's use quadratic formula and see what we have. So for the quadratic formula, we're going to have the two values of a to be negative b, which is just 3 plus or minus the square root of, what is 9 minus 4ac, that is plus. We multiply this by 4. 4 times this time, that will be plus 24, all right? We divide it by 6, okay? Okay, very nice. So let's see what we have. This means a is 3 plus or minus the square root of 33 divided by 6. So in fact, these are the values of a, right? 3 plus square root of 33 over 6, or 3 minus the square root of 33 over 6. So we need to determine which of the following statements is true or are true. So the first statement tells us that no a satisfies the equation. Well, we need to, though we have two values of a, but we need to make sure that these are actually values of a. In other words, these values of a actually lie in this interval from negative infinity to 0, and then from 1 to infinity. Because if this, after simplification, if any of them or both of them lie, if both of them lie in from 0 to 1, maybe with 0 and 1 included, and of course 0 and 1 cannot be included, because if they are, this place will be undefined if a is 0, if a is 0, and then if a is 1. So let's say between 0 and 1, if this lies there, that means those are not values of a. So let's be sure of that. Well, we notice that the square root of 33 is going to lie between 5 and 6. And in fact, 25, the half of 25 and 26, 36, if you look at half of 25 and 36, square root 33 is bigger than half of 25 and 36, which means the square root of 33 will be bigger than 5.5. So let's say it is around 5.7. If you add 3 to 5.7, that will be 8 divided by 6, that will be 1 point something, which means it lies in this interval. Okay, great. If you subtract the square root of 33 from 3, that's going to be around negative 2 points, maybe 7 or so. So negative 2.7 divided by 6, that is close to negative 3 divided by 6, which is close to half. But in fact, that is not 0. Okay, and that numerator is not in between 0 and 1. rather it is in between -1 and 0. So in fact, these two values are actually two values of a. So let's see what we had. The first one tells us that no value of a satisfies the equation. This thing is false. It is false because we've actually found two values of a that satisfy the equation. The second one tells us that an integer a satisfies the equation. As you can see, a is not an integer because we have an irrational number here. So in fact, b is false, right? So let's see what c tells us. C tells us that an irrational number satisfies that equation. Well, this is true. This right here is an irrational number. In fact, both of them are irrational numbers. So at least there exists an irrational number a that satisfies that equation. So more than one value of a satisfies the equation. Of course, the two values of a lie in this interval, so they both satisfy the equation. So the only two correct options we have there are C and D. Okay, that was great, isn't it? Alright, thanks for watching, and please share this video with your friends. Alright, and let me know what you think, or maybe if you have similar questions, integral questions like this, let's handle it for you. Alright, okay. See you in our next video.